Greetings, YouTube. Beautiful mind here. I just got this question that came in from section 4.2, question number 11. Let me think about it. This is from Applied Statistic, AppStats, right? It says find the mean, variance, or standard deviation of the binomial distribution with the given values of n and p. I think this is what we just did today. So if we want to see it, can we use the normal distribution to approximate the binomial? Okay. So first we need to see if we can do that. Let me do it like this. I'm going to do paper. We need to see that first is this: if we do NP and NQ, are they both greater than or equal to 5? If so, we can use the normal distribution to approximate the binomial. So if we do N times P, now I know there was a question about the calculator. So I'm using a 83 plus, like this is a graphing calculator. Okay. So you do need a calculator. I'm using this site called chemtech.net, but then you'd have to also download a ROM or an emulator. It takes a little bit of finagling to get to this point. But yeah, you will need a calculator. Okay. So if we say N times P, let's see. Let's just do 120 times 0.4. So N times P is 48. Notice that's greater than or equal to 5. And let's do N times Q. So if N is 120, P is 4%, so that means that Q, 40%, so that means that Q has to be 60%. So NQ, 120 times 60% is 72, which is greater than or equal to 5. So that means we can use the normal distribution to approximate the binomial. So then our average, our mu in this case is going to be NP, which is going to be 48. So that should be the average. So that should be one of our answers. So then this what was it? Square root. I think the standard deviation was going to be, I got to look up the formula again. I think it's just NPQ. Let me look at the formula again. I think I have it here. The variance, okay, sigma squared, right? So the variance, being sigma squared, is going to be NPQ, okay? So that's going to be 120 times 40 times 60, right? So then that's going to be 120 times 40% times 60%. We get 28.8, and then the standard deviation, which is our sigma, which is going to be the square root of the variance. That's going to be the square root of the 28.8. So in this case, it's going to be square root of NPQ, square root of 28.8, square root of 28.8, like this, approximately. 5.37. So what I worked the view an example. Undo this. Okay. And we get a variance of this guy. I think that's all that the question asks for. Standard deviation of the binomial with the given values of N and P. Okay, let me see, how do we do? 48, 28.8, and 5.37. Yeah, so this is good. Okay. So this kind of follows, but yeah, but you will need a calculator for, this example wasn't too bad. I mean, maybe with this word, yeah, you're going to need a calculator. Like, that's the long and short of it all. Okay. So, but yeah, this was the view and example from section 4.2, question number 11. Okay. On that note, we're going to end the session here, and from one beautiful mind to another, enjoy the rest of your day.